Okay, so today is objective 9.1a, and the skill we are practicing is transforming graphs of sine and cosine functions with a focus on amplitude and period. So we'll be defining those things. Your essential question is, how can I use my knowledge of vertically and horizontally stretching, compressing, and reflecting graphs in conjunction, and there needs to be a C there, now that I see, oops, I don't want to do that. Come back. I just want to fix that. In conjunction with graphing the parent functions of sine and cosine waves. Okay? And so let's start off with some vocabulary. Okay? Really important when we're talking about trig, we always have really specific terminology that lends itself to trigonometry. So amplitude is something that we tend to, what's the word I'm looking for? Associate with waves. Okay, so the amplitude of a function, I'm just using my pencil here. The amplitude of the function is the vertical distance from the midline and that's a vocabulary term all in itself, but you know, the middle line to the peak of or trough of a wave. The vertical distance from the midline to the peak of a wave. The midline being equilibrium, and then the distance from the midline to the peak. So if we were to draw a wave, just draw a couple cycles of a wave. Oh, that's terrible. I'm going to make it look a little better. And let's put a midline in there. So a midline would just cut your wave in half. Your amplitude would be that distance from the peak to the midline. Or you could also go from a trough to the midline. But this is what we call the amplitude. The distance from the midline to the peak. So those would be your amplitudes. Okay? Vertical distance, vertical. Questions? Okay, period of a function. So a period of function is, pencil. The horizontal distance between peaks. Or one wavelength. Or one cycle of a wavelength. So from peak to peak. So if we go back over here to our picture, here's a peak, here's a peak. This measure right here is a period because the wave goes down and back up, and then it goes down and back up. So we consider this here. No, I don't want that. I want that. a wavelength here. So there's a wavelength from peak to peak, okay? And the period is the horizontal distance between peaks. It could also be between troughs, if you'd rather. Tell me I don't hear somebody snoring. I swear I heard some snoring going on. There's a ghost in here. Okay. All right. So today our focus, so those are two vocabulary terms really important, amplitude and period. And we are going to be graphing the sine and cosine functions. So remind me, so here we have the sine function, and you have some space over here so that you can just have the parent functions kind of sketched. No stretches, no compressions, no flips, no shifts, just the parent functions, bare functions. So if we have y equals the sine of x, could you tell me what its period is? A full revolution, right? For a sine function to make a complete wave, you have to go 2 pi, okay? And it has an amplitude of, how high does it go off the midline? The sine function. 1, right? So it has an amplitude of 1, and it has a period of 2 pi, because the height of the sine function wave goes up to 1 or down to -1, depending whether you're at a peak or you're at a valley. And yes, it has a period of 2 pi. So I start with 2 pi, I'll cut that in half to pi, and then I'll cut that in half to pi over 2 and 3 pi over 2. So there's all our quadrantal angles of our sine function. And then remind me, when I'm at sine of 0, what's my sine of 0? 0. And what's my sine of pi over 2? 1. And then my sine of pi, and my sine of 3 pi over 2, and then my sine of 2 pi, 0. All right. So remember when you're graphing these, to indicate on both ends of the graph, sorry, my pen's not working very well, that your graph has a curve in it. So when you go outside of your period, and I'm not restricting your period here, okay, or your domain, just make sure that when you go off the ends of the graph that you're choosing to graph, that you show the tendency of that graph to curve back and go the other direction. Okay, so there's your parent function. So for your sine function, and then of course we're also going to do the bare cosine function, which also has a period of 2 pi and an amplitude of, what do you think? What's the cosine function do? How high does it go? How low does it go? Yes.
Oh, it goes to 1 and -1. But if we put arrows on the test, like on this next test, we won't get dot points.
If I tell you over a closed interval, and you put arrows, yes, then I would mark it down. But only if I say only graph this interval. Okay, so let's graph the cosine function here. Just a little sketch. Now, who's the lagging versus the leading function? Who leads, cosine or sine? Cosine, right? So there you have 1 and -1, and pi and 2 pi, and pi over 2 and 3 pi over 2, cutting those values in half. I would suggest when you go to make your scales, especially if you're not using graph paper, to like start with the complete period and then cut it in half and then cut those distances in half so that you get nice evenly distributed scales. All right, so with your cosine function, the cosine of 0 is 1, and the cosine of pi over 2 is 0, and the cosine of pi is -1, and the cosine of 3 pi over 2 is 0, and the cosine of 2 pi is 1. So you can see from peak to peak, 1 full wavelength. There's your cosine function. So these are the graphs that you will have, these are the graphs that you will start with, and you will transform today. Okay, so there are your parent functions. Just a little reminder of those. All right, so here we have this next part of our notes. Here is the theorem on amplitudes and periods. And these are working off of your wave functions. So it says this: if y equals a times sine of bx, or y equals a times cosine of bx, then the following is true. The amplitude, which I will do in red, is the absolute value of a. It is an absolute value because you're measuring a vertical distance, and distance is always positive. Okay. And then the period I will do in blue. Now the period of both of these functions, sine and cosine, is 2 pi, but you will be dividing it by the absolute value of b. And again, absolute value because you're measuring, in this case, a horizontal distance, and distance is always positive. So instead of multiplying times b, you're dividing by b, because the horizontal, you always do the opposite of what it says. Okay, so here we go. Instructions. Find the amplitude and period and sketch the graph of the equation. So here we have the equation, y equals 4 sine of x. So let's first identify, red pen. What's our a term? What's our a? 4, right? It's right there. Okay, so that's going to affect the amplitude of our graph. The amplitude is the absolute value of 4, or 4. So that means that our range is going to go from the sine -1 to +1 to -4 to +4. So it's really going to vertically stretch your graph. So let's write this down. This is a vertical stretch. The amplitude is a vertical stretch of your y coordinate times 4. Okay. So a little description of what we're going to be doing to our sine function here. Let's also identify our b, because we not only have to find the amplitude but the period. So in this equation, what's your b term? Yeah, it's this invisible one right here. So if that, we're going to take that b term, and we're going to take our formula for period, which is 2 pi, divided by the absolute value of b. So our period is still 2 pi. So there's nothing horizontally happening to this graph. It's just a vertical stretch. So we have to be really thoughtful about how we create our graph. And I'm really looking for you only to draw one cycle of the graph. So mostly we'll work on the positive side of the x-axis. And you're going to want a fairly decent x-axis, or y-axis, because you're going to have to stretch up to 4 and down to -4, because your amplitude of that wave stretched by a factor of 4. So there's 2. Now I'm going to put in my halfway marks, and then I'm going to continue to put in my halfway marks so that I can get a nice evenly distributed scale. And then I'll go out here to 2 pi, because that's my period. So I'm going to go from 0 to 2 pi. I'll cut that in half, pi, and cut that in half, pi over 2, and 3 pi over 2. And I think what I'll do is I'll start with the parent function, and I will vertically stretch it, multiplying my y's times 4. So the sine function starts at sine of 0 is 0. Sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is -1. And sine of 2 pi is 0. So because we're not really asked to graph the parent function, do a dashed line. My dash isn't very good. Apologize. Make yours nicer. It's terrible. Okay. So there's your parent function. Maybe label it y equals sine of x. There's your parent function. So you've got that labeled, and what we're going to do is we're going to stretch its amplitude. So instead of having this little amplitude of 1 from the midline, which is your x-axis, stretch up 1 or stretch down 1, with my red pen, what I'm going to do is I'm just going to indicate with 4 little arrows here that I'm going to stretch this 4 times. You don't have to do that if you don't need that, but I think it's a good visual. 2, 3, 4. Okay. Or you could sit and just multiply all your y values times 4. So 0 times 4 is 0. 1 times 4 is 4. 0 times 0 times 4 is 0. Negative 1 times 4 is negative 4. 0 times 4 is 0. So you can see what happens to your graph. Now you're going to be using a solid line because this is what you were actually asked to graph or sketch a graph of. And just off the ends, get the tendency of the graph to curve. And there you have it. So an indicator of your amplitude right here. Your amplitude is 4 off the midline. Okay, questions? Okay, so if I were to quickly ask you, what's the domain of this function? Okay, negative infinity to infinity, there's no restriction. And what's the range? Closed or open? Closed, negative 4 to 4. So you can see how the amplitude affects your range because your amplitude is a vertical stretch or compression. Questions about that? Okay, then let's move on to the next one. So we have to go through the process of finding our A term. So I'm going to go back to my red pen. What's my A? In y equals cosine 1/4 x, A is 1. So that means that my amplitude is absolute value of 1, which is 1. Okay, so that means that the amplitude isn't affected. You're going to top out max at positive 1 and minimize at negative 1. And then what's our B term? 1/4. So now we'll find our period by taking the period of cosine, which is 2 pi, and dividing it by the absolute value of 1/4, or 2 pi over 1/4, or better, 2 pi times 4, right? Keep, change, flip. So that's a period of 8 pi. Man, that's a major horizontal stretch, right? Because a period of cosine is 2 pi, and I'm quadrupling it. So this is a horizontal stretch where we're going to take our x coordinates and we're going to multiply them times 4. So we'll start off being thoughtful about how we create this graph. The amplitude is not affected. So we'll draw our midline or our x-axis. We don't have any vertical shifts, but we have to really stretch this graph out because we have to go all the way to 8 pi. So we can top out at positive 1 and bottom out at negative 1, which is totally fine, right? I'm going to put 8 pi over here because that's the period of our transformed function. And then I'm, like I mentioned to you already, start by stretching it all the way out and then cutting that value in half. And then cutting that value in half. And try to make a pretty decent scale. And then cut that in half. Apologize. And then, of course, we probably should get the quadrantals in there for at least the original parent function for our pi over 2 and our 3 pi over 2, because the cosine function, without any transformations, needs to pass through those values as well. So first I'll start with the cosine function, where we have cosine of 0 equals 1, cosine of pi over 2 is 0, cosine of pi is -1, cosine of 3 pi over 2 is 0, and cosine of 2 pi is 1. So this is one cycle, or one period, of the cosine function. And what I want you to imagine is that I'm going to grab this end right here, and I'm going to stretch it all the way out to 8 pi, right? So this cycle, all of these points are going to quadruple. So imagine, let's start with this point. This is 2 pi, right? I'm going to go times 4. So that would be 4 pi, 6 pi, 8 pi. So that point, that was at pi, quadrupled. 2 pi times 4 is 8 pi. And let's do the same thing with our minimum down here, pi. Pi times 4 is what? X is pi, so 4 pi. So there it is. And then look at the placement of these two. Our pi over 2 is halfway between 0 and pi, right? So what's halfway between 0 and 4 pi? 2 pi, right? And then 3 pi over 2 is halfway between pi and 2 pi, right? So what's halfway between 4 pi and 8 pi? 6 pi. Or you could just multiply these values times 4. So basically you could say, okay, x is pi over 2. Pi over 2 times 4 is 2 pi. Or look here, it's 1 and then quadruple that horizontal stretch. See that horizontal stretch? I stretched it 4 times. Here, 1, 2, 3, 4. And then this one here, I'm going to just hop 1, 1, 2, 3, 2, 3, 4. So now I'm going to erase those hops because I don't like them. All right, and now we're going to graph. So we're starting here, and we're connecting your blue points. But just imagine you took your parent function, the black function here, and you just pulled it horizontally without flattening it. The amplitude had to stay the same, but the period quadrupled before the wave repeated. Questions? Good? Okay, next. Okay, so we're going to move a little faster now that we've discussed this a bit. Let's identify our A. It's -2. So our amplitude is absolute value of -2, which is 2. So instead of our sine function topping out at 1 and bottoming out at -1, we're going to stretch it 2. And then our B term is 1. And so our period is 2 pi, right? Unchanged. So when we draw our graph, it's really useful to know that where you're going to cap off your y-axis. Since your amplitude is stretched, we're going to go to 2 and -2, right? But our 2 pi is not going to change, so we know our x-axis, we can just go ahead and do one full cycle from 0 to 2 pi, and that will be acceptable. Okay? And then just a little brief description here of what's happening. We do have a negative here. So that indicates that we have a vertical reflection, right? Along with a vertical stretch. So basically what we're doing is we're taking our y coordinates and we're multiplying them times -2. And you're vertically flipping. Oh, Spencer, don't go to sleep. I know you get it, right, Spencer? You get it? Yes? Finish your notes. Okay, so basically what you're doing, because you're doing a vertical flip, is your maximum will become a minimum and your minimum will become a maximum, like that. Your peaks will become valleys. All right, so this is a sine function. So if we were to quickly graph the parent function, and let me grab my black pen here. 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, 2 pi. And so you have the parent function. So there's your y equals sine of x. I believe I forgot to do that on the last graph. And then we are going to affect this graph by changing its amplitude. But we're also flipping it over. So we're going to take 0 times negative 2 is 0. 1 times negative 2 is negative 2. So that maximum became a minimum, and it also doubled. 0 times negative 2, negative 1 times negative 2 is 2. And then 0 times a negative 2 is 0. So your graph has a vertical reflection, maximums become minimums, and it has an amplitude change. And there you go. And this should definitely go like that. No train tracks. Don't draw train tracks on your pictures. Questions? Okay, so let me take a quick vote. Yes?
Do you want us to draw the parent function on?
Not if you don't need them. Not if you don't need them. Absolutely. Okay. So what I'm going to do is D with you, and then I'm going to have you do E and F on your own. So this last one, the reason I'm doing this with you is we're going to have to adjust the way we draw the graph a little bit. So let's take a look at the equation. It's a cosine function. So y equals cosine of negative 4x. So our A is 1. So our amplitude of the cosine function is 1. So it's unchanged. But your B term, blue pen, your B term is negative 4. Okay, so that is going to adjust your period. So we're going to take the period of a cosine function, which is 2 pi, and we are going to divide it by the absolute value of negative 4, which is 2 pi over 4, which reduces down to pi over 2. So that's a shortened period. Basically, what you're doing is you're taking and horizontally compressing your graph and shrinking it. So just a real quick horizontal, we have a horizontal reflection because it's negative, and compression Jesus, I didn't say that, excuse me. Jeez Louise. Horizontal reflection and compression of the x coordinate, because it's horizontal, times negative 1/4. So the graph is going to shrink. So instead of taking the graph and stretching it, you're going to like accordion it. You're going to push the wave closer to it together. So because we are reflecting it horizontally, and our period is pi over 2, we need some of the left side of the x-axis at least to pi over 2. Or negative pi over 2. Thank you. Amanda, before you leave. Okay? So let me just get that cut in half. So that would be negative pi over 4. Then I'll cut that in half. That's negative pi over 8. So this would be negative 3 pi over 8. Okay, so this will be the reflection because I have to horizontally reflect. And this is going to be the period of a full sine wave. Okay? And over here on the other side, of course, we're going to draw, let's put our amplitude in, excuse me, 0, so negative 1 to 1. We're going to go all the way out to 2 pi for our parent function. Question?
After negative pi over 2, what does that say?
Negative 3 pi over 8. Okay. pi over 2, and 3 pi over 2. Okay, so it's the cosine function, and we've got our scale ready to go. We are taking our 2 pi period, we are condensing it to pi over 2. So we're going to take what's sketched here for our cosine function. Oops, that's up there. And we're going to compress it so that it just squeezes into here. So it's pretty much going to go like that. And then we're going to flip it. So if we have this graph, cosine, okay, and I were to compress it by 1/4, I would take 2 pi times 1/4, which is pi over 2, and then I would reflect it to negative pi over 2. What you can do is actually take your x coordinates like I've written here and multiply them times negative 1/4. So you could basically say, okay, so 2 pi times negative 1/4 is negative pi over 2. So the point that was at 2 pi is now, it should be here, by the way, not here. Ooh, I hear you guys. Your teenage brains have kicked in and you need something different. We're almost done. Okay. And that was not a ding on teenage brains. I think teenage brains are awesome. Okay. 3 pi over 2. We're going to take 3 pi over 2 and multiply that times negative pi over, negative 1 over 4. So that would be negative 3 pi over 8. So I'm going to take this point at 3 pi over 2 and reflect it over here and condense it to negative 3 pi over 8. Then I'm going to take this point right here at pi, multiply it times negative 1/4. That gives me negative pi over 4. So this point that was at pi is coming over here to negative pi over 4. And I think that you can see the pattern at that point. And you can see the reflection and the compression. And again, I don't mind if you do these things in steps, like you compress it first and then reflect it, or if you do them both at the same time. That's up to you and your comfort level. Okay, so what I'd like you to do is try these last two where there's a vertical and a horizontal action happening on a sine and a cosine graph. So press pause, try them out, and then come back to the video and let's see how you did. Okay, so you see my work there for your problem E. So take a look at that. I did do an intermediate drawing for the horizontal stretch before I did the vertical stretch. So take a look at that, compare your graph to mine. And then on number F, I did an intermediate graph where I did, I actually color-coded them incorrectly. I did my horizontal compression in red and my vertical compression in blue. So mismatching. Oops, this was supposed to be blue and this was supposed to be red. So take a look at the graphs and there you go. Your assignment is on Canvas. You're doing problem number 2, A, C, E, and G. And you're doing problem number 4, B, D, F, and H. And it is on Canvas. And have a good day.